Okay, we have an acrobatic stunt plane, and it swoops vertically upwards as it ascends. And as it ascends, it gets higher and higher, goes off the power, and allows gravity to take over, to pull it back down. And as it goes higher, it reaches a peak point. And that point is the limit, and that's what we're after. We're after the total distance traveled as it ascends upward to this particular point. We want to find what that point is and that distance, the sum of that distance. So we're looking for the sum to infinity, and that's the point up here. Now, in the first second, as it ascends 120 meters. In the second second, it ascends a further 40 meters. In the third second, 13 1/3 meters. It's so on until it reaches its limit. Okay, what I'm going to do is I'm going to draw a detailed diagram so we can start to understand the whole process for this particular example. Okay, there you have it. We have the biplane, the stunt plane, and it goes vertically upwards and it begins to ascend as it allows gravity to take over, takes off the power, and it reaches that peak point. Now, as I said earlier, in the first second, it ascends upwards 120 meters. In the second second, it travels a further 40 meters. And in the third second, 13 1/3 meters, and so on, as I said earlier, until it reaches that peak limit. So that's what we're after. The total distance traveled is the sum to infinity, the limiting sum. That's what we're after. So the first thing we want to do is check out the data. What do we have first up? What do we have? Well, the first thing we have is the first term. So the first term will be 120 meters. The second term, 40 meters. The third term, 13 1/3 meters, and so forth and so on as it continues to ascend to that limit. Okay, so let's write it out over here. So let's write out those terms. So UN, we're going to have the first term of 120 meters in the first second. Then in the second we have 40 meters. In the third second, 13 1/3, and so on and so on. It continues to infinity, indefinitely. So let's have a look at what we're after. We're after the sum of all these. So we want the 120 plus the 40 plus the 13 1/3 plus, and continue to plus it until we reach that peak limit of that plane's flight in this example. So let's have a look at the sum of those particular terms. So sum to n is, well, the first one will be 120, so let's put that down. And then if we add the first term and the second term, it's going to be 160 meters. And then if we add the next term, another 13 1/3, that will give us 173 1/3. etc., etc., and that will continue as it ascends to that peak point in its flight. So that's the general process. Now, what do we have? What do we understand here? Well, we know that up here, these terms are getting smaller and smaller, and they're converging, and they're approaching what? Well, they're approaching 0 as they get smaller and smaller until we get to that limit. Now, this sum to n is approaching the limit, and that's what we're after. But we have to recognize that n approaches infinity, so it's getting pretty big. So now we can work out what the sum to infinity is. And the sum to infinity, many of you have seen this already, sum to infinity equals a, the first term, all over 1 minus r, the common ratio. Now you may notice there is a constant ratio between each successive term. That's the common ratio, and we're going to work that out right now. So r, the common ratio, is the second term divided by the first term. So we can go u2 all over u1, which is the same as u3 over u2. So let's put it 40 over 120, and that's going to give us our common ratio of 1/3. So we have our common ratio, there it is, 1/3. Now we have the first term, a, which is 120. So the first term is done. Okay, so let's find what that limit is, the total distance traveled as it ascends to that limit. Let's work that out using this formula here. Now, the important thing to recognize is it will reach a limit because the common ratio is a fraction. In other words, it lies between -1 and +1. And as long as that criteria is there, those limits are there, those bounds, it means that it will continue to converge and get smaller and smaller and smaller each particular term along in that distance, meaning that we'll reach a sum to infinity. So let's go back to the formula now. We're going to substitute straight into that and discover how high, what that limit is for this biplane. So sum to infinity equals the first term a, which is 120, all over 1 minus the common ratio, which is 1/3. Okay, sum to infinity equals 120, all over 1 minus 1/3 is 2/3. All we have to do is further simplify that. So let me just work it out over here. So that's going to equal, so if we get 120 and we multiply by the reciprocal of that, times 3/2, cancel, 2's into that goes 60, 3 times 60, and that's going to give us the sum to infinity. So the total distance traveled, the sum of all those particular distances right up to the peak, is going to give us a grand total of 3 times 60, which equals 180 meters. So that peak point is 180. Let me just mark it out here. And there you go, guys.